This is page 280. This is the guided practice. If you're looking for the your turn at the top of page 280, it's on a previous video. Number 1 reads, evaluate each of the expressions in the list for y equals 5, then draw lines to match the expressions in list A with their equivalent expressions in list B. So what I'm going to do here is I'm going to kind of, maybe a little bit messy. Basically I need to take all the y's out and put 5 in its place. So on the first one, 4 plus 4y, y is equal to 5. So I'm going to put a parenthesis there. 4 times 5 is 20, because 4 right next to y means 4 times y. So if I take y out and make it 5, it's 4 times 5 is 20, plus 4 is 24. And on the next one, I'm going to put y right here. And since 5 minus y is inside parentheses, I have to do that first. 5 minus 1 is 4, times 4 is 16. And on the third one, I've got 5 times 4, that's 20, plus 1 is 21. I'm going to do the same thing over here. I'm going to replace y with 5, and I get 4 times 5. That's 20. Minus 4 is 16. And that matches up with this one. And then on my second one, I've got 5 plus 1. That's 6. 6 times 4 is 24. And that matches up with this one. And on this one, I've got 5 times 4 times 5 is 20. Plus 1 is 21. All right, we're on number 2. Number 2 reads, determine if the expressions are equivalent by comparing the models. Well, I kind of hope you recognize they're not, because they're close though. Because if you just count on the left, we've got one x value. The big ones are the x values. That's an x. And on the right, we have 2 of them. And so they're not equivalent because they're not the same size. If I had one more of these right here, then they'd be equivalent. I just don't. So they're not equivalent. It's just, they're not the same picture. They don't have the same amount. They're not equivalent. And we don't have to do anything else besides that. Okay, we are on numbers 3 and 4, and the directions say, for each expression, use a property to write an equivalent expression. Tell which property you used. So what could be equal to a times b? Well, it can just be b times a. And what property states that it's okay to change the order? That's called the commutative property of multiplication. The word commutative means they move. The property, the multiplication means that this is a multiplication problem. So instead of writing a times b, we should just write b times a. We just changed the order. Now number 4, I hope you recognize by now, is a distributive property. Whenever you see a number outside parentheses followed by an operation inside parentheses, that's called the distributive property. So I'm gonna solve it in just a minute, but I'm gonna right off the bat title it distributive property. Distributive property. And I'm gonna use a whiteboard for this. And I've shown this a few times, and it's tricky, so please be patient with your learning. It's 5, 3x minus 2, and the distributive property states that you multiply the number outside the parentheses by everything inside the parentheses. So I'm going to do 5 times 3 is 15x, and I'm going to do 5 times 2 is 10, and I'm going to do subtraction. And that's what I'm going to put, this is what I'm going to put on the line right here. Now what I just said was that 5 parentheses 3x minus 2 is equal to 15x minus 10, and that's true. That is the answer to this question. All right, let's move on. Numbers 5 and 6, the directions read, use the properties of operations to determine if each pair of expressions is equivalent. Is the first one equal to the second one? And the property we're going to use in both cases is the distributive property. Basically what I'm going to do here is I'm going to say 1/2 times 4. Well, half of 4 is 2. That's a good sign. Now I've got 1/2 of 2x. What's 1/2 of 2x? Well, 1/2 of 2 is 1. And this expression over here is 2. They're not equivalent because 1/2 of 2x would be 1x. So if this was a 1, we'd say equivalent, but since this is a 2, it's not equivalent. and I could show that slightly more. I could probably show a little bit more work if I make a whiteboard here. I'm going to solve this. I'm going to use the undo. I'm going to use the distributive property on the one on the left. 1/2 parentheses 4 minus 2x. I'm going to show you what this is equal to. 1/2 times 4 is 2. And 1/2 times 2, well, 1/2 of 2 is 1x. And so this expression, 2 minus 1x, is equal to this expression. And this expression, 2 minus 2x, is not equal to 2 minus 1x. These are not equal to each other. They're different. It's just because I have 2x's instead of 1. That's why I have to write the words not equivalent. All right. It's kind of a little bit of a mess, but it's okay. I think I'll extend my whiteboard here so I can do number 6. All right, number 6 is 1/2 parentheses 6x minus 2, is that equal to 3 minus x? We're about to find out. What is 1/2 of 6x? Well, 1/2 of 6 is 3, and then I've got an x here, so it's 3x. And what is 1/2 of 2? 1/2 of 2 is 1. Is 3x minus 1 the same as 3 minus x? It is not. 3x minus 1 is not equal to 3 minus x. The answer is not equivalent. In both cases, they gave us numbers that looked like they could be equivalent, but in both cases, they're not. Okay, number 7. Combine like terms. Like terms are when we have the same variable to the same exponent. The y's are the same in both terms, so we simply get to add up 32 and 12. We get 44y. The answer to number 7 is 44y. Number 8. What do we have that's like? Well, we've got some x's and we've got some regular numbers. Pay attention to the fact that I've got 3x minus x. 3x minus x is 2x. And now I've got 12 and 12, but pay attention to the fact that it's 12 minus 12. And 12 minus 12 is 0, so I don't even need it. You could put, plus 0, but you don't need to. The answer to number 8, very simply, is just 2x. It's 2x because 12 minus 12 is 0, and 3x minus 2x is just 2x. So that all simplifies, or it all gets combined to just 2x. Number 9 reads, describe 2 ways to write equivalent algebraic expressions. Well, one way to do this is to combine like terms like we're doing on number 7 and 8. So one thing you could do is you could combine like terms. Or what we did on 5 and 6 is that we could use properties. And often the properties are like the distributive property. So those are the two options. You can combine like terms or you can use properties. Okay, great job. You are done with page 280.